Okay, let's have a look at this question here. So we have to write down the coordinates of the center of the circle. Okay, that looks okay. We'll just expand this here. So we have y squared equals 10x minus x squared. So we'll get x squared minus 10x plus y squared equals 0. So we'll get x minus 5 squared plus y minus 0 squared equals 5 squared. So that's x squared minus 10x plus 25 plus y squared minus 25 equals 0. So the center of the circle is 5, 0 with radius of 5. That's for S. Prove that that line is a tangent. Okay, well, if we calculate the perpendicular distance, that would be 3 times 5 minus 4 times 0 plus 10 over the good old square root 3 squared plus 4 squared, which is 5. So that's 15 over 5. Uh-oh, that didn't quite work out. 15 over 5 is 3. Must have done something. I must have written the number down wrong. Let's have a quick peek here. 3 times 5 minus 4 times 0 plus 10. Oh, I just didn't see my 10 at the end there. So that's 25 over 5, which is equal to 5, which is equal to the radius. So that proves that it's perpendicular. Okay. So prove that that line K is a tangent to the circle. Oh, well, I guess perpendicular, i.e. a tangent. Sorry, i.e. therefore a tangent. Okay. Now, the tricky part is find the coordinates of the point of contact. So we could solve as a simultaneous, but it might be easier to do something else here. I'm just going to have a quick sketch. So interestingly, 5, 0, so it means the circle would be just like that. And 5 is there. And our tangent line, if I just rewrite this a little bit, well, I see that it crosses. If I was to put x as 0, that would make y equal to 10 over 4, which is 5 over 2, which is 2.5. So if that's 5, then it's here. And then if I was to make y is 0, if y is 0, then x would be 10 over 3. So let's just mark that in. 10 over 3, 3.33. So that would be about there. I must have a sign mistake. When x is 0, y will be that, and when negative 3.33. So like something like here. So there we go. That'll be the tangent. So we're looking for this point here. I think we can get the slope of this line. So I can say y equals 3 over 4x, etc., etc. So the slope of this line is 3 over 4. Okay. This distance here is 5. So I'm starting here. This is at minus 10 over 3. and then I'm going up in a 3/4. So every 4 units I go out, I have to go up 3 units. So I'm going across like that. So I need to hit a point here where that distance is 5. Is there any obvious way to find that? No. Okay. I don't think so. Let me think. No, I don't think so. I don't think there's any obvious way, so I'll do something else instead. You know what? Maybe it would just be easier to sub it in, because this equation doesn't look too bad. So maybe I will just sub it in. So here I can get I want to get the y or the x. I'll get the y. Y equals 3/4x plus 10/4, which of course is 5/2. So if I sub that in, I get 3/4x plus, I'm actually going to leave it as 10/4 for the moment, squared equals x times 10 minus x. So I'll multiply both sides by 16, and that will cancel them there. So now I'll have 9x squared plus 60x plus 100 equals 160x minus 16x squared. This is looking good, actually. 25x squared minus 100x plus 100. Oh, I'm glad I did it this way. This is working out pretty nicely. So that's 25x squared. That's 6 minus 100x plus 100. Divide by 4. So you get x squared. Divide by 25, I mean. X squared minus 4x plus 4 equals 0. So that's x minus 2 squared equals 0. So that's good. There's only 1 point. So x is 2. And if I put 2 in here, I can get the y. So that would be just a bit of rough work here. 3/4 times 2 plus 5/2. 2 cancels there. 3/2 plus 5/2 is 8/2, which is 4. So the point is 2, 4. Okay, so that's the point of contact. The line K cuts the x-axis at P and makes an angle theta with the positive sense of the x-axis. Let F be the anti-clockwise rotation of measure 2 theta about P. Find the equation. Okay, I'll just write 2, 4 here, because I might need that. And I'll just remove this here. Okay. We'll just do a quick sketch again. So that sketch I had earlier, I actually need it for this last part. Okay. So let's draw. We have here at the point 5 our circle. And then here at the point 2, 4 is the tangent. And earlier I mentioned that this crosses at minus 10/3. And the line K cuts the x-axis at P, so that's P. Minus 10/3, 0. And makes an angle theta here with the positive sense of the x-axis. And F is an anti-clockwise rotation measure of 2 theta around P. Find the equation of Fs. So, okay, what's going to happen? The radius of the circle isn't going to change by rotation. It's only the center. So, F is an anti-clockwise rotation of measure 2 theta about P. So I think what they're saying is that I start here and swing it around 2 theta. Okay, cut the x-axis at P and make an angle theta with the positive sense of the x-axis. Let F be an anti-clockwise rotation of measure 2 theta about P. Yeah. So this is going to get moved. There's another theta here. Will that S pass through here? I wonder. I guess I could calculate the distance and then I would know. But I don't know if that helps me. So I can do this rotation using matrices, but that's not on the course anymore, so I have to think of another way to do it. And I can also do it pretty easily using parametric equations, but that's not on the course anymore. But still, I think I definitely need to get the distance here. So I'll call that center, I don't think it has a letter yet, C. So the distance PC will be 5 plus 10 over 3, which should be 25 over 3. So I'm out here, swings up there. I could draw a triangle. I know that tan theta is 3 over 4. So to get the slope of tan 2 theta, now tan 2 theta, what's that formula? That's 2 tan theta over 1 minus tan squared theta, I think. So that would be 3 over 2 over 1 minus 9 over 16. I'm feeling lazy, but I don't have my calculator. It's on the other side of the room. Okay. That's 3 over 2. 16, 7 over 16. So that's equal to 3 over 2 times 16 over 7. That goes in there 8 times. That's 24 over 7. So that's the slope there. So I'll just draw a triangle. And this length here is 25 over 3. So I need to find, I know these are in the proportion of 24 to 7. So I'm sure I do a quick Pythagoras and I can figure it out. Let me make a bit of space. See, I think there's a 7, 24, 25 triangle. I think. Let me have a quick Google here. 7, 24, 25 triangle. Let's have a peek. Yeah, that is a Pythagoras triangle. So it means that the lambda is 1 over 3. So this side here is 24 over 3, and that's 7 over 3. That's 7 over 3, and that's 24 over 3. Okay, so 3. So I figured out where this point is. It's going to be at minus 10 over 3 plus 7 over 3 and 24 over 3. So the C dash will be at minus 10 over 3 plus 7 over 3 and 24 over 3, which is equal to minus 1, isn't it? Minus 10 plus 7 is minus 3, so that's minus 1, and then 24 over 3 is 8. Well, that's really, really nice. So now I can get the equation of that circle. So Fs the rotation would have me at x plus 1 squared plus y minus 8 squared equal to the radius squared, 25. So that's where the new circle will be. So I don't think I'll make a second video for this because everything worked out so nicely. It doesn't have to be right, but it gives me confidence that I did everything right here. You know, I wasn't even expecting it to be so nice that I'd end up with integers for the new coordinates after rotating through 2 theta. But the 7, 24, 25 triangle there was really, really nice. So, and I didn't have to get my calculator out of my bag. So I'm quite happy with this question. Let's just check that I didn't miss anything. Write down the coordinates of the center of the circle and find the length of its radius. Prove that that line is a tangent to the circle and find the points of contact. Let K cut the x-axis at P. That makes an angle theta with the positive sense of the x-axis. Fs is the anti-clockwise. Make sure I didn't mix that up. Anti-clockwise rotation of 2 theta around P. Find the equation of Fs. That is the rotated circle. And the radius of the circle is not affected by rotation. Only the center of the circle is. Yeah, I'm happy with that. Very happy with that. And, this took a minute or two longer than I expected. Probably because I was considering a different approach to finding the point of contact. If I just committed straight to the substitution technique, I would have been done sooner. No dilly-dallying, that's the lesson. Alright, thanks for watching.